Hello everyone, my name is Subrata Nizam and today I'll be presenting on entity relationship diagrams, also known as ER diagrams. ER diagrams is an essential tool in database design because they help us to plan the structure of a database before we actually build it. So in this presentation, I will explain the concepts behind the ER diagrams and then apply those concepts to the physician or office reminder assignment. So what exactly ER diagram is? So ER diagram provides a logical view of the data in a system. Instead of jumping directly into creating tables, an ER diagram helps us to map out everything in a clear, organized way. It includes entities and their attributes and the relationships between them. In this diagram, before the foundation for creating an accurate and efficient database, especially in systems where data is connected in multiple ways. So, what is an entity? So, an entity is a real world object or concept about which we want to store information. In a database, entities are represented as triangles, and each entity has attributes that describe it. For example, in our assignment, a patient is an entity because the physician office needs to store information about each patient. Similarly, reminder is an entity because the office needs to store the subject, body, and the ID of each reminder message. So, entities actually help us to break the system into meaningful components. So, coming to what is a relationship explains how two entities are connected. So, it helps us to answer the key questions like which patient received which reminder or how many reminders were sent. So, they are represented using diamonds in the ER model and show interactions between the entities. Also, they help us to define how data should be stored and linked in the final database, ensuring that the information is not lost or duplicated. So, coming to the assignment scenario, now let's apply these concepts for now. So, a physician office wants to send an email reminders to the patients. So, to do this, they need a database that stores the information about the patients, the reminder themselves, and send in the history. So each patient has a name, address, and email, and the email address acts as a unique identifier. And each reminder has a reminder ID, subject line, and a body content. So finally, the office wants to record the data on which the reminder was sent, which makes the relationship meaningful and trackable. So what are the entities we used here? In this problem, there are two main entities that are patient and reminder. So the patient entity includes attributes such as email, name, and address, as I said before, and the reminder entity includes attributes such as reminder, ID, subject, and the body. So each entity plays a different role in the system, and together they form a basis of a database. So this clear separation of entities help us to avoid the duplication and keeps the system very organized. So, what is this sent relationship? So, the key interaction in this scenario is that the reminder is sent to a patient. So, this interaction forms a sent relationship. So, sent date attribute belongs to this relationship because it does not describe the patient or the reminder alone. It describes the action of sending. So this relationship helps the office know exactly when the each reminder was delivered to whom. So without this relationship, the database would not be able to, track the communication history. So, so here's the ER diagram for the physician reminder system. So this ER diagram illustrates the structure of the physician reminder. It shows the how patient and the reminder entitles are connected through the sent relationship. The diagram also includes the attributes and the primary keys for each entity as well as the cardinality between them. So here you can see that patient is uniquely identified as the email and includes the name and the address. Reminder entity is includes with the reminder ID, subject, and the body as I mentioned before. And sent relationship tracks each reminder sent to a patient with sent date. And here the cardinality is the one patient, many sent records, and many reminders. So coming to the next thing, so understanding the cardinality. So how cardinality works is that cardinality describes how many instances of each one entity can be associated with instances of another. So it is one of the most important concepts in the ER modeling. So there are three types of cardinalities: one to one, one to many, many to many. So understanding these relations can help us to ensure the data is stored properly and that the relationships reflect the real world rules. So I'll explain one by one in the next things. So one to one example is like one to one relationships do not appear directly in this assignment, but it is really useful to understand them. So one to one relation means that one record is in an entity matches exactly to one record in another entity. So an example might be a patient and the unique health profile that only belongs to that patient itself. Even though the assignment does not require this type, one-to-one relationships help us to understand when data should be separated into multiple secure tables. And coming to the next slide, one-to-many. The assignment clearly includes the one-to-many relationship. A single patient can receive multiple reminders over time. This means one instance of the patient entity is associated with many instances of the sent relationship. So this type of relationship is very common in the database design, and it helps to support the repeated interactions, like ongoing communications all the time. And coming to the many to many relationship, is that in this scenario also includes a many to many one. A reminder can be sent to multiple patients and a patient can receive multiple reminders. So because of this, the sent relationship acts as a bridge and or an associative entity between the patient and a reminder. It stores the send date and connects their primary keys. This kind of relationship types captures the complexity of the real world systems where interactions happen multiple times. So, here I would like to conclude that ER diagrams are extremely valuable in the planning and designing a database. They help us to break down a system into entities, attributes, and relationships, creating a clear structure and a very organized database um, before writing any code. In our assignment, the patient and the reminder entities are connected through the many-to-many relationship that is resolved through the send table. Understanding this kind of ER diagrams give us the foundation need to build accurate, efficient, and well-organized database. Thank you for listening.